So on page 16, is everybody on that page with me? So on page 16 of your problem solving packet, is everybody on this page right here? 50-gram sample of calcium carbonate reacts with 13 grams of hydrochloric acid. So hopefully you have this with you. Are you with me? Are you with me? Oh yeah, we're with you. Okay. Now that I just kind of like talked about a quiz and laid down the hammer, sorry. So it says work them out with the 107 method versus 111A. I'm just going to do the 111A method. Okay. So I just want to go through again just the procedure for doing an amounts table and limiting reactants in general. So what's the first thing we should do? Write a reaction down, right? I'm going to leave some space above here so that way I've got room to show it in the order I kind of want. What is the reaction?
Calcium carbonate plus hydrochloric acid gives you calcium chloride plus carbonic acid and water.
Right, so calcium carbonate and reacts with HCl. We're actually going to do this reaction tomorrow, so I guess it is a bit fitting. Okay. And then to balance it, you got a 2 in front here. So when you do the reaction tomorrow, when you're doing the lab, you'll see gas bubbling out. This will be the gas coming out, carbon dioxide. Okay, so we got a balanced equation. We're going to use this to make an amounts table. Bless you.
Thank you.
Okay, so now that we've done that, what do? Do you remember? In order to find the limiting reactant, we have to first find the number of moles of each one, right? So I'm going to do that above here. So we have, how do we know this is limiting reactant, by the way? Like if we look at this problem, I mean, it asks for how many grams of calcium chloride, but the 2 masses it gives us are those 2 masses of each reactant, or is there a product mass in there? So,
2 reactants.
yeah, two reactants, right? So we're given quantities of 2 reactants. So because of that, we know we've got to figure out which one runs out. All right, that tells us it's limiting. If you only have one quantity of one reactant, then it's not going to be a limiting reactant. It's just going to be the simple, more simple stoichiometry type problem. All right, so we got 50.0 grams of calcium carbonate. And the molar mass of that is 100.09. Alright, so that comes out to be 0.500. Alright, that's going to go right in our amounts table here. I'm carrying 3 sig figs just because I'm given 3 sig figs in the mass. Right, so I probably should carry one more, but just for the sake of for our HCl, we've got 13.0 grams of HCl. One mole of HCl for every 36.46 grams of HCl. That comes out to be 0.357 moles of HCl. All right, that's going to go in here. What values go for the products?
Zero.
For initial products, they're always 0. Zero for all those. Okay, so which one's limiting?
Is the moles of hydrochloric acid?
So if we divide 0.500 by 1, and if we divide 0.357 by 2, whichever of those two comes out the smallest is going to be limiting. So I'm going to go ahead and just do that down here. Find the LR, limiting reactant. Okay, for calcium carbonate, it's going to be 0.500 divided by 1. That gives me 0.500. For HCl, 0.357 divided by 2. That gives me, I think it's about 1.78, something like that. So the HCl is smaller, therefore it's the limiting reactant. So with that, what do we do in the table then once we find out which one's limiting? Yeah, subtract HCl. Since that's limiting, we're going to go ahead and subtract the moles of HCl from everything else, including itself. We will have no HCl left over. I'm going to take that same number and put it in all the other columns. When I do the product side, the minuses turn into pluses. In order to be able to add or subtract moles of HCl to the calcium carbonate, okay, or add moles of HCl to moles of calcium chloride, I've got to convert all the units of moles of HCl to the moles of whatever's in that column. So to do that, I got to use my stoichiometry to do that. So what is going to be my ratio for the calcium carbonate column?
2, 1.
Yeah, it's going to be 1 over 2, not 2 over 1. Right, so it's 1 mole of the calcium carbonate over 2 moles of the HCl. All right, this column is the limiting reactant, so we don't need to worry about stoichiometry for that. This is going to be 1 mole of calcium chloride for every 2 moles of HCl. This will also be 1 over 2, and this will also be 1 over 2. I don't suppose this is any better. Oh yeah, that's a lot better. So 1 over 2, 1 over 2, 1 over 2. And it's always not dividing by 2 because the limiting reactant coefficient's 2. Okay. Okay, so at this point we can just do some math. We can subtract 0.357 times a half from 0.500. So that comes out to be 0.5 minus so this will come out to be 0.32 15 moles of calcium carbonate left over. And all of these other ones will end up becoming 0.178 moles of whatever it is, calcium chloride, 0.178 moles of carbon dioxide, moles of water, same thing. And the question asked us what grams of calcium chloride is produced. So do we need to worry about these other ones? And the answer is no, we don't. But I just wanted to show you how you would get it if you had to get them. So we're going to take our final moles of calcium chloride and we're going to convert that back to grams and we're done. All right, so we have 0.178 moles of calcium chloride times 110.98 grams for every 1 mole of calcium chloride. And that gives us, based on sig figs, 19.8. Now, if the question asked how many grams of CO2 was produced, how many grams of water was produced, how many grams of calcium carbonate are left over, that'd be really easy for you to answer because you just multiply each respective moles by the molar mass of that compound, and you'd be done. All right. So I think I wanted you to see this again because the first time you see it, it's kind of a little bit overwhelming. Questions? Yeah.
Yeah, for the final.
Uh-huh.
For the, I should be at 0.325.
Right, so what I'm doing is I'm taking 0.357 times a half, which comes out to be 0.178, and I'm subtracting that 0.178 from my 0.500. So you're actually, you're taking this entire bracketed quantity and you have to subtract that from the initial. Some people, what they do is they'll take 0.5 minus 0.357 and then they'll times by half and they'll get the wrong answer. So just be aware that you got to take this whole quantity and subtract it from the initial moles. All right. Anything else? You want to try some on your own now? We got half hour, we can do one. All right, let's do it.